While decoder systems offer many initial advantages in reduced labor of installation, the troubleshooting of these systems is not as easy as it might seem. The average technician who is comfortable with the use of simple multimeter and traditional residential irrigation systems may find that his skills are stretched by the complexity of decoder-based systems. There are two major differences that make decoder systems more complex to troubleshoot. First, the operation of the entire decoder system relies on the integrity of the two-wire path. This two-wire path is used to activate every valve in the system. In a conventional system, each valve has its own wire. To open a specific valve in a decoder system, the controller calls on the specific decoder associated with that valve. The controller knows that the decoder's unique numeric address and sends it as a coded signal. This causes the decoder to switch on, allowing the energy to flow from the two-wire path to the valve solenoid. Because valve solenoids are after the decoder, it's not possible to use traditional resistance measurements with an ohm meter to measure the health of the circuits. Instead, we will demonstrate use of a clamp meter to measure current flow. This second significant difference of decoder systems versus conventional systems is the number of wire splices. Decoder-based systems have twice the number of wire splices. In the case of the valve on the far end of the two-wire path, the current often has to pass through dozens of splices before reaching the solenoid. Because the wire loop is continually energized in most decoder systems, corrosion can be a powerful enemy to these wire splices. Many two-wire systems use a multi- or modified DC current, which can accelerate corrosion of poor splices and causes wires to separate. In many cases, you will find corrosive dust or separated wires in valve boxes where splices were made improperly. If you have a decoder system with a problem, bad splices will more than likely be the culprit in the majority of cases. If splices have been made hastily or improperly, the technician will face a difficult and time-consuming process to check each to source problems far in the system. Every splice made in a decoder system should always be placed in a valve box for future examination. Because decoder systems operate at a voltage between 30 and 36 volts, the National Electric Code specifies a standard burial depth of 24 to 36 inches for all wiring components. This protects the system, but it can also lead to extra digging work when making repairs. In this video, we will review the basic principles of decoder system troubleshooting. In our second video, we will cover specific procedures to review specific issues. While there are many different brands and models of systems on the market that have individual differences, we will focus on the troubleshooting steps and methods common to each. Note that many controllers have onboard diagnostic systems that can help you identify the type of fault and where it might be located in the system. Always refer to the manufacturer's manual to take advantage of these features. The diagnostics will not tell you how to solve the problem, but they will help you to know where to look. Before attempting to troubleshoot an existing decoder installation, you need to have specific system information and materials. Obtain an accurate, as-built drawing showing the wire path and decoder locations and the number of decoders on each wire path. A volt-ohm meter, multimeter, capable of reading 0 to 5 volts AC/DC and resistance from 0 to 1 million ohms. A clamp meter for measuring AC current with a precision of 1.0 milliamps. Use of a clamp meter is an absolute requirement with decoder systems, and a meter with added sensitivity is required for use at the valve level. A clamp meter can read electrical current in a wire simply by closing its jaws over the outside of the wire. You will see in a decoder system that this feature will be used to trace issues throughout the wire path. Wire tracing and fault finding equipment for following the wire path versus the plan and identifying breaks in the wire. Spare system components including spare decoders, solenoids, wire splice kits, and wire strippers. Problems with decoder systems are often discovered when the controller displays error or alarm messages. The sophisticated main controller will often have onboard diagnostics. This can help the troubleshooter be aware of specific problems. The challenge is knowing where to look to resolve these. In other cases, problems will be discovered because individual zones or entire groups of zones won't activate. In either case, we start by eliminating the controller as the source of the issue. With the system in run mode, the 2-wire path should be energized with between 24 and 30 volts AC. You can read this output with the standard volt setting and the test probes. We will also assume you have eliminated any programming issues, including setting up proper addresses for decoders at the main controller. Note that one model of controller requires a station to be activated in order to have power in the wire loop. A special note, if your 2-wire path loops back to the controller, you'll need to disconnect one leg of the loop from the controller or power source to complete troubleshooting. You can also take a spare decoder and connect it directly at the controller to verify that the controller is operating properly. A common rookie mistake is to assume that the controller itself is the source of field issues. In a vast majority of reported problems, the issue will be in the field wiring. Some controllers' diagnostic features will prevent them from powering a wire path that has faults. In this case, it may be useful to power the loop with a single plug-in transformer power source. In our second video, we will cover the essential steps in troubleshooting specific faults with the decoder system.